Swimmers, it's Mrs. Belatesh here. Great to see you. Happy New Year. I am so excited to start a new year. I think everybody is. I hope you had a nice break, and I hope that you had fun with the engineering challenge of building a boat before the winter break. And maybe some of you continued to do some of that building over the break. It's a lot of fun. So I want to do just a quick little review about some of the key things we learned. We started this unit talking about water and how water interacted with different types of material. Some material it soaked in, some it just rolled off. Then we talked about what happens when things get hot, right? What happens to water when it gets hot? Hot water rises and cold water sinks. And it's the same thing with air. Hot air rises and cold air sinks. And that kind of led into our boat building. Now we're going to talk about what happens to water when it freezes, when it turns from a liquid to a solid. I'm going to do a little experiment where we can see what happens to liquid water when we get it very cold. So I have a syringe like this, and right now it is empty. Now it's full of air, right? It's full of gas. So I'm going to push all the gas out, and now I'm going to put some green food coloring in it, and I'm going to put 15 milliliters of green colored water in the syringe. And I'm also going to add some green water to a small cup. And I'm going to fill it up right to the top. And now I'm going to put it in the freezer. Okay, I'm now in the teacher's lounge at school, and we're going to put these containers in the freezer. So I have 2 syringes. They both have 15 milliliters of water in them, and we're going to put them in. Right now they're liquid water, and I have 2 cups of green water that I'm going to put in the freezer. So my liquid water is now placed in the freezer. The water is right up to the top of the cups, and it's at 15 milliliters in the syringes. We're gonna leave it alone for a couple of hours and come back and check on it. Okay, so we put our liquid water in the freezer, and we're gonna see what happens to that liquid water when it gets really cold and freezes. Now, while we're waiting for that to happen, I have some ice. I have 3 plates of ice. I have 1 plate of ice that I'm going to put in the direct sunlight. I have 1 plate of ice that I'm going to put in the shade. And I have 1 plate of ice that I'm going to put in the shade, but covered up by a bunch of dirt. And I'm going to see what happens to the ice in those 3 different locations. Here's my first plate of ice. I'm putting it out on the playground. It is 12:28 p.m. and I'm going to leave it in the sunshine. Here is my second plate of ice. It is in the shade, and it is 12:30. And hello, bunnies. How are you today? Oh, those bunnies are so cute. All right, we're gonna pay attention to the ice. This is what it looks like now. Here's my third plate of ice, and I have a bag of soil, and I'm going to cover the ice up with the bag of soil. I didn't want to just put dirt on top of it because I want to be able to remove the soil and see what's happening with the ice. And it is 12:33. Oh, and look, there's Pepper. Hi, Pepper. Okay, it is 30 minutes after the water went into the freezer, and look, there is starting to be some water being pushed out of the vials, and nothing's really happening with the water in the cups yet. Okay, 30 minutes. It is 30 minutes later, and we can see that in the sunlight, the ice is melting. It's going from a solid to a liquid. So 30 minutes later, this is what the ice looks like. This is the plate of ice that's in the shade. And you can see that there's quite a bit more ice still as a solid. Not as much ice has melted and turned into a liquid. Okay, now I'm going to take off the bag of soil and see what the ice looks like underneath. Okay, not very much of the ice has melted. There's a little bit of melted water, but mostly the ice is still solid. Let's compare it to this one. You see there's a lot more liquid in this one, less liquid here. So the soil seems to be providing some type of an insulation effect. Okay, now look at this. The water has frozen mid-drip. So the water was being pushed out, but it froze into a solid, and now it's just hanging there. And we're going to continue watching this for a little bit because it doesn't look like it's completely frozen solid. And let's take a look at this. It looks like the water is going above the cup. It didn't start out like that. And it's still not completely frozen. So we're going to come back and take a look at this again in about 30 minutes. It's 1:30 and there's absolutely no solid ice left. All of the solid ice has melted and turned into liquid water. It's 1:31 and a lot of the ice has melted, but not all of it. There's still chunks of solid ice on the plate that was in the shade. Here is the plate that was covered with the soil, and it has a lot of pieces of ice, large pieces of ice that are still left in there. Oh, here are some chickens saying hello. Hello. They're wondering what kind of experiment I've got going on now. Hello, Pepper. Hi, Fuzz Lightyear. Back to our experiment. So the soil seemed to keep the cold in, so the ice did not melt. I have taken the syringes out of the freezer so we can take a look at them closer. So remember, it was 15 milliliters of water that I put in there, and it has increased by 1 milliliter. It was pushed out, and some water was dripping out. That is now solid ice. Same thing with this syringe. It was originally 15 milliliters, and now it is 16 milliliters, and a drop of water is in mid-drip there. Now let's take a look at the cups of water. The water was, as it was freezing, it was expanding, and you can see that this one started to drip over, and the water froze in the middle of that process. So when water freezes, it expands. It takes up more space. When matter expands because it takes up more space, it becomes less dense. We saw that with hot water and hot air. So, and things that are less dense float. I have a piece of the green ice, and I'm putting it in a cup of water. And what is it doing? Well, it's floating. which is a little weird, right? We talked about how cold things are dense and they sink, and most cold things are. Ice is something that is special. Ice, the molecule of water, is like a magnet. And remember when we talked about magnets earlier and we had things that were attracting and repelling? When the water freezes, those positive and negative or north and south poles of the water molecules make the water expand when it freezes. And when the water expands, it becomes less dense and it floats. We did so many experiments today, and what I'd like to do now is to take out your science notebook and let's put a few notes in our notebook so that we can remember for the future what we learned today. So the first question is, when we put the syringe in the freezer with the water in it, and we put the small cups in the freezer with the water in it, what did we observe? We observed that water expands when it freezes. Let's write that down. The next question I want us to talk about is what happened when we put ice in water? What did we see? Ice floats in water. If ice floats, what does that tell us about the ice? Ice is less dense than water. Let's write that in our science notebook. So when water freezes, it becomes less dense, it floats. But then we did some other experiments where we added heat to ice. And what happened to the ice? It melted. And it melted in different time periods. When ice is in direct sunlight, it melts faster. When ice is in the shade, it melts slower. Most importantly, when the ice was protected, was insulated by the soil, it lasted the longest. Animals can use this idea of warming up in the sun, cooling off in the shade, or digging a burrow to stay cool to help them survive. All right, we did a lot of good work today, Cougars. Looking forward to talking to you next week. Bye.